Thanks to its extraordinary details, the James Webb Telescope provides us with a more complete view of the cosmos as we know it. Today, we will explore the James Webb Telescope, a marvel of human ingenuity that could revolutionize everything we know about the universe. But before we continue, please like this video and subscribe to the channel. The vision that brought Webb to life. It all began in 1996 when the idea of a space telescope capable of surpassing the limitations of Hubble was first proposed. The international scientific community felt the need for a more advanced instrument, one that could observe the first galaxies formed after the Big Bang and peer deep into the gas and dust clouds where stars and planetary systems are born. Three distinct groups of scientists and engineers, from various public and private sectors, came together with the goal of evaluating whether NASA could indeed accomplish such a feat. After careful analysis, all three concluded the same: the telescope, as ambitious as it was, could be built. This was the first step in a long and complex journey. In 1997, NASA decided to fund further studies to analyze in detail the technical and financial requirements of the project. The idea was to create a telescope that, operating in the infrared band, could penetrate cosmic dust and gas, allowing us to observe the primordial universe. The challenge was enormous: to build a telescope sensitive enough to detect faint signals from billions of light years away, and at the same time, ensure it could survive and function perfectly in space for over a decade. The birth of a legend. By 2002, NASA had chosen the teams to build the main components of the telescope and formed an advisory group of scientists to assist in the construction process. That same year, the telescope was officially named the James Webb Space Telescope, JWST, in honor of the former NASA director who significantly contributed to the development of the Apollo program, a figure who embodied the dream of expanding humanity's frontier in space. When engineers and scientists began constructing Webb in 2004, it was clear that technologies never before developed would be necessary. It wasn't just about building a larger telescope than Hubble but about conceiving an entirely new generation of scientific instruments, capable of surviving in space without any possibility of direct human intervention. Unlike Hubble, which could be repaired and upgraded by astronauts, Webb would operate over 1 million kilometers from Earth, too far for any rescue mission. Challenges and innovations. The engineers of the James Webb Telescope had to overcome numerous technical obstacles. For starters, the telescope's main mirror, a technological masterpiece made up of 18 hexagonal segments of beryllium coated in gold, had to be perfectly aligned and sensitive to the smallest temperature variations. Even the slightest imperfection could compromise the mission. The sun shield, an essential component designed to protect the telescope from the sun's heat, represented another monumental challenge. This shield, as large as a tennis court, had to be robust enough to withstand the space environment, yet light enough to be transported into space. Composed of 5 ultra-thin layers of kapton, the sun shield was designed to keep Webb's instruments at extremely low temperatures, crucial for infrared observations. Between 2012 and 2013, the assembly of Webb's main components entered the final stages. Webb's unique scientific instruments, including the near-infrared camera, NIR-CAM, the mid-infrared instrument, MIRI, and the NIR-SPEC spectrograph, were carefully installed and subjected to intensive testing. These tests simulated the extreme conditions of space, with temperatures ranging from scorching to freezing and vibrations that could have damaged the delicate instrumentation. The long journey to the stars. Finally, after years of meticulous preparation, the James Webb Space Telescope was ready for launch. However, the journey to space represented yet another challenge. Webb had to be folded into a compact configuration to fit into the Ariane 5 rocket that would carry it into orbit. Once in space, it would have to unfold in an extremely complex and delicate sequence, with over 300 critical points where even a single error could compromise the entire mission. On December 25, 2021, Webb was launched into space, beginning a month-long journey to its final destination, the Lagrange point L2, about 1.5 million kilometers from Earth. During the journey, the telescope went through a series of deployment phases, including the opening of the sunshield, the deployment of the secondary mirror, and the alignment of the primary mirror segments. Each phase was a moment of high tension, but the mission team successfully executed each operation, bringing the telescope to full operation. How does the James Webb work? Space missions are often described in overly simplistic terms, but the James Webb is not just another space camera, it's something entirely different. Its true power lies in its ability to observe infrared light, a type of radiation invisible to the human eye, emitted primarily as heat by distant celestial objects. Infrared light is particularly valuable to astronomers because it can pass through cosmic gas and dust, which appear as an impenetrable fog to optical telescopes. This allows Webb to capture detailed images of objects and phenomena that have remained hidden from our view until now. For example, Webb can observe the first galaxies formed in the universe, study the regions where stars and planets are born, and even search for signs of life on planets beyond our solar system. Webb's ability to detect infrared light is crucial for studying distant galaxies. Since the universe is expanding, light from these galaxies is stretched during its journey to us, shifting from visible or ultraviolet to infrared. This phenomenon, known as redshift, means that only telescopes with infrared sensitivity, like Webb, can observe these objects and better understand their evolution. A journey through time. A fascinating aspect of astronomy is the ability to travel back in time by observing distant objects. Light travels at a finite speed, so when we look at galaxies billions of light years away, we see them as they were billions of years ago, shortly after the Big Bang. This means that the James Webb is not just a tool for observing space but a time machine that allows us to study the early stages of the universe's formation. Thanks to Webb, researchers like Daniel Einstein, an astronomer at the Harvard-Smithsonian Center for Astrophysics, can observe galaxies as they form, studying their sizes, compositions, and structures. These studies will help us understand how galaxies, including our Milky Way, have evolved over billions of years. Exploring stars and black holes. In addition to exploring distant galaxies, the James Webb is designed to study stars, particularly those forming in dense clouds of gas and dust. These regions, known as stellar nurseries, are where new stars are born, but they are so thick that visible light cannot penetrate them. However, infrared light can pass through these clouds, allowing Webb to reveal the process of star formation with unprecedented detail. The telescope will also be a crucial tool for studying black holes, the most mysterious and fascinating objects in the universe. Although black holes cannot be directly seen, Webb will be able to observe how they affect the surrounding stars and gas, providing new clues about these enigmatic cosmic objects. Webb's infrared capabilities will allow scientists to study the coldest gases and stars orbiting black holes, revealing more details about their nature and role in the evolution of galaxies. In search of new worlds. Finally, Webb is an exceptional tool for studying exoplanets, planets orbiting stars other than our Sun. With its advanced spectroscopic capabilities, the telescope will be able to analyze the atmospheric composition of these distant worlds, searching for signs of chemical elements that might indicate the presence of life. Such observations could radically change our understanding of humanity's place in the universe, bringing us one step closer to answering the question, are we alone? A new chapter in cosmic exploration. In conclusion, the James Webb Space Telescope is much more than a telescope. It is a symbol of what humanity can achieve when science, technology, and international cooperation come together to explore the deepest questions about the universe. Webb will not only help us see farther into the cosmos but also allow us to explore new frontiers of knowledge, addressing fundamental questions about the origins and evolution of the universe. Its advanced capabilities go beyond simply observing distant galaxies and star-forming regions. They will significantly impact various scientific and technological fields. With Webb, we are on the brink of new discoveries that could rewrite everything we know about the universe, offering us a deeper understanding of our existence and our place in the cosmos.